minus 5y equals negative 12, and negative, and the other one is negative x plus 4y equals 9.
All right. This is solving simultaneous equations, or solving a system of equations. This one has two variables, x and y. You might have three equations and three variables, x, y, and z. But as long as it's a 2 by 2, it's relatively straightforward. The other thing about this problem is they're both in standard format, right?
Right.
I mean, they're not in y equal mx plus b format. They're in standard format, where you have your x and your y on the left side, you have the number on the right. Whenever they're in this format, you want to solve them by elimination. Remember the two methods? Elimination and substitution.
Yeah.
Use elimination when they are both in standard format. So, what do we have to do to one of these equations in order to eliminate a variable?
We have to set one equal, like, another one.
If the bottom one had minus 2x already, then we could just add the two equations and the x term would go away. But it doesn't. It has minus x. So how can we make that look like minus 2x on equation?
Multiply everything by 2.
Okay, so let's do that. So now it's
Or
minus.
multiply everything by positive 2.
No?
No.
I'm going to leave it negative because the next step is going to be to add the two equations together. And you'd rather add than subtract. It's permissible to subtract equations also, but it's easier for most people to add than it is subtract. So when I add equation 1 to equation 2, what do I get?
You get 3y equals 6.
So y equals 2. Now how do I solve for x?
You can plug it into either one of the equations, but
Any of the three. Any of these three equations you can pick. So pick the simplest one.
so the negative x one.
Yeah. That's simple for a couple of reasons. First of all, it has the smallest numbers of any, all of the numbers are the smallest. Second of all, it has a positive coefficient on the y, which is, that doesn't really matter in this case. We solved for y, so we're going to plug in for y into this equation. So I got minus x plus 8 equals 9. What's x equal to?
It's equal to 1.
Negative 1. If minus x plus 8 equals 9, then minus x equals 1,
Oh, okay.
which means x equals minus 1.
Okay. Yeah.
Got another one?
Yeah. So then this one is the same thing, except it's asked how many solutions there are.
Okay.
And so it's 8x minus 4y equals 20. And then 2x minus y equals 20.
All right.
Or I mean 5. For 2x minus.
That makes the difference between no solution and infinitely many. Now there's a couple of ways to approach this. One, we could just try to solve it. Let's do that. and then we'll talk about the other. That's equation 1, that's equation 2. If we're going to try to eliminate a variable, what do we need to do first?
We can multiply either side by 4.
Both sides.
Or we have to multiply the second equation by 4.
Okay, but we have to multiply every term by 4, not just one side. So that's our new equation 2. Now what?
Now it just becomes 0 equals 0.
Okay, whenever you get by subtracting the two. In other words, first of all, it's very important to specify whether you're going to add the equations or subtract them. In this case, we'd subtract them because we have an 8x there and an 8x there. So when we get 0 equals 0, that means infinite number of solutions. If you get 0 equals a number, that can't possibly be correct. That means no solution. Anything else is going to give you an x or a y value, and you'll have solutions. So the only two odd cases are when you go to solve it, you get a number equals a number, and it doesn't matter if it's 0. If you get 2 equals 2, that means infinite many solutions also. But if you get a number equals a different number, that means no solution. Now, why is that infinitely many solutions? Well, talk briefly about it. I don't want to use the whole session up, but let me go to another page. If I tell you this, x plus y equals 10, how many solutions does that have?
Infinite?
Yeah. X could be 1, y could be 9, x could be minus 5, y could be 15. I could go on and on forever. In other words, when you have two variables and one equation, you always have infinite number of solutions. Well, if I give you a second equation that is merely a multiple of the first, if I tell you, well, here's a second equation, I haven't added any information, right?
Yeah.
So there's still, even between these two equations, that has to be an infinite number of solutions, because it's not really two equations, it's really only one equation. Okay, well, if we look at that last problem, our second equation was 2x minus y equals 5. Well, if I multiply this by 4, I merely get the first equation again. They didn't really give you two independent equations. And when you have two equations that are the same thing, you have an infinite number of solutions. Now, let's consider another possibility. If xy equals 10, and I say, well, also, x plus y equals 9, that is no solution. Why? If I subtract the bottom equation from the top, I get 0 equals 1. That can't be. There's no way x plus y could be equal to 10 while at the same time being equal to 9. That's impossible. Impossible means no solution. Okay? So there's the conceptual way to look at it, and then there's just, you wouldn't have to know any of that, but when you go to try to solve it, if you get 0 equals 0, that means infinite. If you get 0 equals 1 or some other number, that means none, or no solution. So that might be the easiest way to remember it. All right, you got another problem? In that area? In other words, let's look at some more problems where we're trying to figure out whether we have none, infinite, or 1.
No, we don't have any more of those. We only have one.
Well, that's all right. Let's just go to other problems you have.
All right. So these are just solved algebraically ones.
Okay.
So x plus y minus z equals -2. 2x minus y plus z equals 2. Or 8, I mean. 8.
Now, that by itself isn't enough information. I got 3 variables, only 2 equations. So what's the third equation?
Then there's another one. -x plus 2y plus 2z equals 10.
Do we know if this has a solution or not?
No.
I think it does. In other words, I always do a quick check of these to see if the left side is a multiple. Is any of those lines a multiple of one of the other ones? No. These all have coefficients of 1. This has a coefficient of 2 in front of the x. These have coefficients of 2 in front of the y and z. So there's no way we're looking at the left side being multiples of anything. So I would come to the conclusion, okay, this looks like it'll produce a solution. Let's proceed. This is a little complicated and lengthy. This problem will take 5 minutes at least on its own, maybe 10. First step is to pick a variable, eliminate it, and produce a fourth equation minus that variable. So which 2 equations can we play with to eliminate a variable right away?
The first and the third.
What do I have to do to them?
You just have to add them together.
Okay, so that's going to produce equation 4, which is 3y plus z equals 8. Okay? Now, play with the other 2, any 2 out of the other 3. I could play with 1 and 2 or 2 and 3, and eliminate the same variable, so that we produce an equation 5 that is just in y and z.
Alright. So, if you multiply the top one, or number 1 by everything by 2, then subtract them,
Good.
you'll get rid of the x.
Okay, what do we get for equation 5 then? So this is my new 1. What are we going to subtract 2 from 1?
Yeah.
Okay, what do you get?
Y minus 3z minus 2.
Let's see, I'm doing minus 4 minus 8, right?
Oh, yeah. Wait, yeah.
Minus 12.
Minus 12, yeah.
Okay. Now notice we have a much simpler system. We have 2 equations and 2 variables. We know how to solve that. Let's solve that. What do I do now?
You can multiply the fifth one by 3, then subtract them.
Okay.
Or,
Is there an easier way?
I don't know, what I would do is actually substitute.
No, you don't want to go to substitution. In other words, when you have these things in standard format, where both variables are on the left and only numbers are on the right, elimination just works so much easier, I think. Now, you can use substitution, although you're liable to get a problem on the test that says use elimination to solve this. So let's make sure you're good with elimination. So you weren't wrong. I can multiply 5 by 3. Make sure you multiply every term by that. Now subtract them. What do you get?
you get 10z plus 40, or then 42. How's it 42? Oh, yeah.
Okay. So now we've got z solved. Now we can go back into any of these equations and solve for y, any of those three.
So the top one?
Yeah, the top one's probably the easiest one. Maybe not. Maybe the second one is the easiest because it's already got a y with a positive coefficient all by itself. I'd go into the middle one. So y minus 3 times 44 tenths equals minus 12. Now, obviously they're not making it easy on us. Why they would do that, I have no idea. That is lunacy, making these fractions. In other words, if the point of this exercise is to teach you how to do it, then why bring fractions into it? So anyway, rather than spend all this time doing the arithmetic, I got an answer for y right there. So y equals something. Now you got z solved for, y solved for. You can go back into any of your original equations and solve for x by substituting for y and z.
All right.
That's how you do 3 equations and 3 unknowns. And remember the concept. You produce equations 4 and 5 that are both missing the same variable. That's the key. You don't want an equation 4 that says 3y plus z and then have an equation 5 that has the x still in it. In other words, if I had an equation 5 that said this, well, I can't solve that. That's 2 equations and 3 variables. So I can't go anywhere with that. So when you produce equation 4 and 5, make sure that it has the same 2 variables you have. In other words, when you produce equation 5, make sure it has the same 2 variables that are in equation 4. Your goal is to get it down to 2 equations and 2 variables that are the same. Solve that system and then work backwards and solve for each variable. Once we got one solution here, once we got z is equal to this, then we know that it has a solution, that the answer is not no solution or infinitely many. All right, what else you got?
I'm looking for a couple more. We have so much review stuff.
Not bad. That's what I'm running into is I'm having hour-long sessions with people and they've got 50 questions and we only get through 20 of them.
Yeah, it's bad.
So
and
you and I are going to have another session, right? Before your
yeah,
final? What I would suggest is before we have our next session that you go through, in fact, we're going to have an hour-long session, I believe.
Yeah, on Tuesday.
Make sure that you go through and maybe circle the ones you want to go over so that we don't waste time going over stuff that you don't need to go over.
Yeah. I found some I need to work on.
Okay. What?
So it's synthetic division stuff. So it's x cubed minus 10x squared plus 27x minus 12 divided by x minus 4.
Okay. What is the string of coefficients that goes across the top of my synthetic division?
It would be squared, but like, yeah,
it's the coefficients of each variable. In other words, it's 1, minus 10, 27, and minus 12.
Okay.
If there was no x term, I would need to put a 0 in there. In other words, you have to account for every degree of x. What goes in my little box over there?
4?
Yes. It's the solution, not the factor. The factor is x minus 4. But if that is a 0, then the 0 is 4. Right? Okay.
Yeah.
So you always put the solution to the problem, not the linear factor. Okay. Now what?
Now, you don't do anything to the first one.
You bring the 1 down. That's
Yeah.
always the first step, is bring whatever this number is down below the line. Okay, now it's a process of multiplying and adding, multiplying and adding, multiplying and adding.
All right. So it's 4 in that next slot, and -6, and then -24, then 3, and then 12, and then 0.
This 0 is an important 0. That 0 tells us that x minus 4 does divide evenly into this thing. If I got any other number other than a 0 here, then x minus 4 would not be a factor and 4 would not be one of the zeros. But the fact that I have a 0 over here tells me that 4 is a solution. If I plug 4 in up here into this polynomial, this whole thing will equal 0. Okay? What is the resultant quadratic that is produced by this division? In other words, when you divide a cubic by a first degree linear, you get a quadratic. What is it?
X squared minus 6x plus 3.
So that polynomial is produced by multiplying x minus 4 times that quadratic. If you multiply that times that, you'll get that. We could have also gotten this by long division. In other words, just doing long division at the top would have given us that same answer.
All right. Can we just do the same problem but just long division?
Yes. It's the first step in the long division process.
Do you multiply, so you have to get
Long division.
the x cubed.
Long division. The first step is going to be divide.
Oh.
Divide x into x cubed. That's the first step.
So you get x squared.
Now multiply that by both terms.
Right. So it's x cubed minus 4x squared.
And now we're subtracting. The difference between synthetic and long division is with long division you're always subtracting, with synthetic division you're always adding. Well, notice on the synthetic we were dealing with a plus 4, not a minus 4. That's why. You always, in the box, you always have the opposite sign, which turns it all into addition instead of subtraction. Okay, now let's subtract. X cubed minus x cubed is 0.
Yeah. And it's negative. Oh no, it's
You got a minus 10 minus a minus 4.
So it's -6.
Bring down the next term. Stir and repeat. You can leave out the stir. Just repeat. What's the next step?
Next step is to get
Divide x and
divide
that term there.
So it's 6x.
How about minus 6x?
Oh, yeah. Well, yeah.
Okay, and then multiply.
So it's minus 6x squared minus plus 24x.
Subtract.
3x.
Bring down the next term.
12.
Do the whole thing again.
So it's just 3.
Multiply. You get 3x minus 12. The final subtraction produces that same 0. As long as we get a 0 remainder, we know that x minus 4 is a linear factor of that cubic. If we don't get a 0 remainder, we know it is not. Okay, we've got a few minutes left. You have a last problem you want to look at?
Yeah.
Okay.
So it's another long division one.
Okay.
So x to the 4th plus x cubed minus 3x minus 3, and then divided by x plus 1.
Now notice what's missing in the polynomial.
X squared.
Okay, well let's add it. Let's put that negative
So
sign
it-
there, and let's add a 0x squared. Now we have every degree polynomial. Okay?
Yep.
Goes here,
X to the 3rd.
goes down here.
X to the 4th plus x to the 3rd.
Now subtract.
It just comes up to 0.
Bring down the next term. Repeat.
So is it just plus 0?
What's x into x squared?
Oh, x.
Now multiply.
It's x squared.
Wow. Hold on a second.
You didn't, because
Did
you
something wrong. What did I do
didn't
wrong?
bring the 0. You didn't bring down the 0. Because you
Oh, I
added
brought
the
down,
next
yeah,
zero.
you're right. I brought down a 1x. I want to bring down a 0x, which means nothing. So x divides into that 0 times, multiplies back all zeros, subtract, bring down the next term.
And still, is it 0 again?
Wow. I've not encountered this where both of these terms go to 0. Right there. And then you
Yeah.
bring down a 0 third next term.
So is it just x squared minus 3x?
Hey,
Or
what?
minus 3?
Well, I'm not positive, to be honest. Let me think about this a second. I've never run into this. If I divide x into that, it's minus 3, but what I really need to do is bring down all the terms. In other words, at that step, I need to bring down both the 3x and the 3. And now I get minus 3, and that works. And then I get a 0 remainder. So I imagine the answer is x cubed minus 3. But to be sure, let's do it by synthetic, because I think that will solve any problems that we might have as to the order of operations here. Let's divide this whole thing by 1, and I got a 1 there, a 1 there, a 0, a minus 3, and a minus 3. Let's see what happens when we do this thing synthetically. Notice that when we do it synthetically, there is no problems whatsoever. And we got our answer, x cubed minus 3.
So if I'm unsure about the answer, just do it both ways?
I would do it synthetically, always.
Oh, okay.
I mean, you could see that we ran into confusion problems when we did it by long division. I did. But when we did it synthetically, there were no problems at any point. This answer is x cubed. We know we're starting with a quartic, dividing it by a linear. We're going to have x cubed minus 3.
All
right, Mitch. I will talk to you next time. What?
It was Monday.
It was Monday?
Monday and Tuesday.
Monday
Yep.
at 4 for an hour and Tuesday at 4 for a half hour.
All right.
Okay?
Yep.
Talk to you then.
All right.
Good night. Bye-bye.